Okay, so the next thing we are doing is the orthocentre. And unlike the centroid formula, the orthocentre is actually quite a lot of hassle to find. There's no easy formula for it. So first of all, if you remember, what is the orthocentre? Orthocentre is the intersection of the lines that are perpendicular to each side of the triangle that go through the opposite vertex on the triangle. So for example, this line here is perpendicular to this side. I'll do a different color, yellow here, perpendicular to this side, and it goes through this point A on the triangle. This one here is perpendicular to this side and goes through point A. It's where they intersect. Okay, so that is what the orthocentre is. It's the intersection of all three. So to find the orthocentre though, we don't have a formula, as I said, so we need to use a method. So I've labeled these A, B, and C. And what I'm going to do next then, I'm going to label this line here that's perpendicular to AC. I'm going to label that W. So W is perpendicular to AC and goes through B. And I'm also then going to label this line here. I'm going to label that Z. Okay, so we'll just call that Z. So what I need to find basically is where W and Z intersect. To find out where two lines intersect, remember we use simultaneous equations, but to use simultaneous equations, we need the equations of Z and W. So need equations of Z and W, the lines Z and W. What do we know about Z and W? Well, I know W is perpendicular to AC, so I can find the slope of AC and then get the slope of W. Then using the point B, which is on W, I can find the equation of that line. And same sort of situation for this line here, Z. So I'm just going to write out all those steps and break it down. So my first step is going to be finding the slope of AC. So AC was this line. So the slope of that using the formula, I'm going to do that. Once I've got that slope, I'm going to flip this slope to get the slope of the perpendicular. So the slope of the perpendicular here would be this line here. Okay, so if I flip the slope of AC, I will get the slope of what we've named W. So I'll actually type that in. So the perpendicular to AC, which is called W. Using this slope and the point B, get the equation of line W. So this is what I wanted to get. I wanted to get the slope of the equation of W. I now have this slope if I've followed these steps, and I have a point on that line B, so I can use that to get the equation of W. Likewise, I'm going to repeat all of this for AB. So first of all, I get the slope of AB using the formula. Then I flip that, get the slope of this perpendicular. Then using the point C and the slope of this, I would get the equation of the perpendicular to AB, which is Z, line Z. So that's how I get the equation of line Z. Then what we do, use simultaneous equations to find the intersection of W and Z, and that's the orthocentre. So as you can see, it's quite a time-consuming process. It's nothing really that new. It's just more annoying to have to put it all together. So we'll try to do this as quick as we can. So my first step anyway is going to find the slope of AC. So I have my 2 points, A and C, 0, 3, 4, minus 5. I need the slope, so I'm going to use the formula from the log tables, which looks like this. I need to find what my x1 and y1 values are. Obviously, that's just going to be this, x1, y1, x2, y2. Subbing them in quickly then, we end up with minus 5 minus 3 over 4 minus 0, which is equal to minus 8 over plus 4, which is equal to 2. I actually mean it's equal to minus 2. Okay, minus 2 there. Okay, so we have that slope. So the slope of this flipped would be minus 2 over 1. Remember, flip them and change the sign. Okay, so that is my new slope, the perpendicular slope. That's going to be the slope of W. So putting that into our thing here. So we know that the slope of AC is minus 2. The slope of W then is going to be 1 over 2, positive 1 over 2. Using this slope and the point B, get the equation of the line W. So sorry, I forgot to say as well, to get the slope of the perpendicular, flip the slope as well, change the sign. change sign, so I just forgot to write that in. That's the rule for perpendicular slopes. Anyway, 1/2, and we're going to the point B. Remember our point B is 7, 4 here. So our slope is 1/2. We're getting the equation of W. 7, 4 is point B on the line. Formula from the log tables for equation of a line. So y minus 4 equals 1 over 2 x minus 7. So multiply the other side by this. 2y minus 8 equals x minus 7. And then just simplifying it down, we end up with x minus 2y is equal to minus 1. So that is the equation of W there. And we can put that into the steps. X minus 2y minus 1. So x minus 2y equals minus 1. So we have the equation of W. We're now going to do the same thing exactly for the line AB. So first we'll find the slope, then we'll flip it to find the slope of the perpendicular line Z. Then we'll use the point on Z, which is 4 minus 5, to work out the equation of Z. So using my points A and B, we can find the slope using this. So it's going to be 4 minus 3 over 7 minus 0, so it is 1 over 7. That means our flipped slope is going to be, so the slope of Z is going to be minus 7. Sub this into our equation for equation of a line. Sorry, a formula for the equation of the line. What point are we going to use? Well, we have the slope, we need a point. Remember that this equation is the one that here, so we know that C is on it, 4 minus 5 is going to be the point that is on it. So 4 minus 5, x1, y1, minus 7 is our slope. Y plus 5 equals minus 7, x minus 4. So equals minus 7x plus 28. We end up with 7x plus y is equal to 23. So that's my equation of Z. So I'm going to go put that into my thing here. 7x plus y equals 23. So now we have the two equations. We can use simultaneous equations to find the intersection of W and Z. So we need to get rid of either the x's or y's. I'm going to get rid of the y here by multiplying the bottom line by 2. So we end up with then x minus 2y equals minus 1. 14x plus 2y equals 46. They're gone. We're left with 15x equals 45, x equals 3. Then we'll use either of these. I'll use the x minus 2y equals minus 1. Replace x with what we found x to be, 3, to find our y value. So 2y equals 4, y equals 2. Okay, so after all that time, all that hassle, we found that the orthocentre is this, and the reason it's that is because it's the intersection of the two perpendiculars that go through opposite points, so 3, 2. Okay, so from our diagram we can see, obviously my diagram's a bit off here, so it should be 3, 2 around here. So it's a bit off anyway, but that's why the calculation works, because I only did a sketch of this. But yeah, so that's what it was. The 3, 2 is our point, our orthocentre. So it's no harm to do a sketch of the diagram just to know what you're doing. It's no harm as well to just do the steps. Write a note to yourself what the steps are, and that is your orthocentre there. So it's quite a long process. Just make sure you follow the steps along the way.